Hi folks, welcome to the lesson. It's going to get a bit tricky today, but don't worry, you're going to cope. So let's strap myself in and get the job done. As an introduction to this, we're going to be multiplying out two brackets. The difference between this and the previous video that I've done on multiplying out two brackets is this. First of all, each bracket contains a surd, and in fact it's the same surd, root 2. The fact that it is the same surd is key. And the other thing is the form of each bracket is very similar. One is A plus B, the other is A subtract B. And when we have those two brackets in that form, what you will see is the surd disappear when we multiply out. That's key, and let's see it. There are different ways of multiplying out two brackets. I'm going to use the grid method. So we've got the first bracket on the top row, which is 2 plus root 2. And down the column, we've got the second bracket, which is 2 subtract root 2. Then when we do the multiplying, 2 times 2 is 4. Then it's 2 times positive root 2, which is positive 2 root 2. Then it's negative root 2 times 2, so that is negative 2 root 2. And finally, negative root 2 times positive root 2. Well, a negative times a positive will give us a negative, and root 2 times root 2 is root 4, and root 4 is just 2. So our final insert there is negative 2. Putting all that together, we obtain 4 subtract 2, which is 2, and then positive 2 root 2 subtract 2 root 2. So the root 2's cancel out. Therefore, our final answer is just 2. Here's a second example. Note once again the structure of the question. It's an A plus B, A subtract B format, and we're going to see once again that the square root part disappears. On the top row, I've got 3 plus root 5, which is the first bracket, and in the first column, I've got 3 subtract root 5, which is the second bracket. 3 times 3, that gives us 9. 3 times positive root 5 is positive 3 root 5. 3 times negative root 5 is negative 3 root 5. And finally, negative root 5 times positive root 5, positive times a negative is a negative, and root 5 times root 5 is root 25, which is just 5. So we end up with our final cell being negative 5. Then when we put all that together, 9 subtract 5, that gives us 4. And then positive 3 root 5 subtract 3 root 5, they cancel out again, so 4 is our final answer. Note in the last two examples, we've seen the square root disappear from our answer, and that's key. Therefore, to rationalize a denominator means to rid ourselves of the surd part of the denominator. A rational means a number that can be expressed as a fraction, and a surd cannot be expressed as a fraction. So if we have a surd in the denominator, we need to rid ourselves of that surd. And to do that, if the denominator is 1 subtract root 2, we multiply by 1 plus root 2. Think of that as being the opposite of the original denominator. 3 plus root 5, we would multiply by 3 subtract root 5. And if the denominator is 2 subtract 3 root 3, can you think what we would multiply by? we would multiply by 2 plus 3 root 3. So let's see that in action. So we multiply by the opposite of the denominator, so it would be 1 plus root 2. As we've seen in those previous two examples, when we have an expression of the form a subtract b and a plus b, then the square root part, the surd part, disappears. Now, we can't just multiply the denominator by 1 plus root 2 and not do anything to the numerator, because that would change the value of the fraction. In order to keep the original fraction the same value, whatever we do to the denominator, i.e. multiplying it by 1 plus root 2, we must multiply the numerator by the same thing. So we multiply by the numerator by 1 plus root 2 as well. And quite simply, what you can see highlighted there, 1 plus root 2 divided by 1 plus root 2, well, that's just 1. And multiplying by 1 clearly doesn't change the value of something. So there are two things there. One is we're multiplying by something here, which is 1, so it doesn't change the value. And the denominator we pick is the opposite of the original denominator, so it's 1 plus root 2. And 1 minus root 2 times 1 plus root 2, we will lose the root 2 from our answer, I promise. Let's do the multiplying out then. First of all, we're going to work out the denominator, which is 1 minus root 2 times 1 plus root 2. 1 times 1 is 1. 1 times negative root 2 is negative root 2. Root 2 times 1, that's root 2. And finally, root 2 times negative root 2 is negative 2. And when we put that together, we end up with negative 1. The 1 take away 2 gives us negative 1. And the negative root 2 and the positive root 2, they cancel out. So our answer in the denominator, 1 minus root 2 times 1 plus root 2, is negative 1, which is rational. And that's only part of the question, because we've also got to multiply the two numerators. So we need to work out 2 plus 3 root 2 multiplied by 1 plus root 2. 1 times 2 is 2. 1 times 3 root 2 is 3 root 2. Root 2 times 2 is 2 root 2. And finally, 3 root 2 times root 2. Well, root 2 times root 2 is root 4, which is 2. And we're timesing that by 3, which will be 6. Just take your time and make sure you understand where we get 6 from in that last cell. When we put our answers together, we end up with 8 plus 5 root 2. 2 plus 6 gives us 8. And we have 3 root 2 and 2 root 2, which together make 5 root 2. Now, our final answer is 8 plus 5 root 2. That is the numerator, but remember the denominator is negative 1. If we look up here, remember the denominator, 1 minus root 2 times 1 plus root 2 is negative 1. So we have 8 plus 5 root 2 divided by negative 1, and that just gives us negative 8 plus 5 root 2. Now there's a lot to that question, so please take your time. First of all, you have to understand, what do you multiply by? Then you have to multiply the two denominators carefully, and then you have to multiply the two numerators carefully, and then put those two answers together. Here in part B, first thing, what will our denominator be? Well, the opposite of 1 plus root 3 is 1 subtract root 3. And remember, we need to be multiplying by something which is 1. That there is clearly 1 because we've got the same numerator and denominator. So the numerator and denominator must be the same. And we pick the denominator to be the opposite of the original denominator given to us. So 1 plus root 3, the opposite of that is 1 subtract root 3. Then we're going to multiply the two denominators. Very quickly, 1 times 1 is 1. 1 times root 3 is root 3. Negative root 3 times 1 is negative root 3. And negative root 3 times root 3 is negative 3. And we put that together, we end up with negative 2 because we have 1 subtract 3, which is negative 2, and root 3, take away root 3, that cancels out, and so we're just left with negative 2. Now we need to multiply the two numerators together. So that's 3 plus root 5 multiplied by 1 minus root 3. 1 times 3 is 3. 1 times root 5 is root 5. Negative root 3 times 3 is negative 3 root 3. And then finally, negative root 3 times positive root 5 is negative root 15. And so when we put those four things together, none of them go together. They're four separate things. We just end up with 3 plus root 5, subtract 3 root 3, subtract 15. That expression, unfortunately, doesn't simplify, which means our final answer is 3 plus root 5, subtract 3 root 3, subtract 15, and then divided by, don't forget, divided by negative 2, which was our answer to when we multiplied the two denominators together. And so to simplify this answer, we would just take that negative there and put it up at the front in the numerator. And that would be our final answer. Let us put all this together then in a recap. To rationalize means to turn a number into one that can be written either as a fraction or a whole number. A surd is not rational, it is irrational. To rationalize root a, you can multiply by root a, because you'll end up with root a squared, and the square and the root cancel out and you're left with just a on its own. If you have 1 divided by root a, then you would multiply by root a over root a. That way, the two numerators, root a and root a, when multiplied together, leave you with something which is not a surd. If your original fraction has a denominator of a plus root b, then you would multiply by a subtract root b over a subtract root b. The two key parts here. One, if you multiply by that expression there is 1, so you are not changing the value when you multiply something by 1. And the other thing that's important is this denominator here is exactly the same as the denominator here, except the plus has become subtract. That's key. Think of it as being the opposite. Plus root b is the opposite of that is subtract root b. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.